So yesterday, I think we were trying to understand that a cloud area is basically a combination of four different technologies at its best. Okay, all the four technologies which we have mentioned in this image: distributed computing, hardware evolution, internet technologies, and system management will basically have an overlap at its best. So that is where your cloud operates. And then we have tried to draw a very simple image, okay, of an airline reservation system. And then we were trying to discuss some of the issues. So for example, what would happen if the database is crashed? So how will we mitigate that? So then we said that there will be a secondary database. So what would happen if your whole data center has gone for a toss? To mitigate those kind of scenarios, we would say that rather than having one data center, we'll have both. That is a kind of a rich man solution. A poor man solution would be possibly taking a backup of four of this, and when something goes wrong, you will recover all of that. It would take time, but it works out. That was the other option. Okay. Now, today we had to start at a point where we try to understand that everything is going good, but what will you try to do? Yes. Let me open this notes section. Yeah. 1 minute. Yes. Okay. So what we were trying to tell is everything is going good over here. What will you try to do? Okay, if the traffic on your website has increased a lot. Okay, this was the point where we were struck yesterday. So, for example, in airline system, I have availability checker. Now, due to some holiday season, there is a lot of traffic, and there are a lot of bookings on our website. Okay, there are lots of tickets that are generated in our system. So, can our system work smoothly? So, for example, okay, here we have to understand one interesting thing. Okay. Scaling, or let me put limits. Every server will have limited hardware resources. Yes or no? So you might call it as 32 GB of RAM or 64 GB of RAM, but that is limited. Okay. So every machine will have limited amount of hardware resources, and these resources can cater only to certain limit. For mathematical understanding, let us assume that our availability checker can parallelly give a response to 5,000 users. I'm just making it simple for mathematical observation. Okay, our availability checker. So 5,000 people can parallelly check for availability of tickets on our airline system using this one server. But actually, we have a traffic of 25,000 now. What should we do? What do you think is a better solution for us? Did you understand this? So let me write that question. Okay. Example scenario. Okay. Our each server component like availability checker can respond to 5,000 parallel users or requests, whatever you call it. Okay, but right now we have, okay, let me not make 25,000. Let me just make a simple stuff. Let me say that we have 10,000 users. Now, what do you think is a better solution for us? Yeah. So exactly in these cases, there is a concept, okay, solution for the above scenario is scaling. Scaling is increasing. Okay. So scaling is of two types. One is called as vertical scaling. The other one is called as horizontal scaling. One is vertical scaling. The other one is horizontal scaling. Okay. So what do I mean by vertical scaling? Okay. So vertical scaling is increasing hardware resources of the current server. So for example, you have 32 GB of RAM. You have made it 64 GB of RAM. I call it as vertical scaling, or generally that is considered as vertical scaling. So vertical scaling is increasing the resources of your server. That could be a solution to this. Or horizontal scaling is increasing number of servers doing the same job. Okay. So now with availability checker, right? When I say horizontal scaling, I'll increase the number of servers. When I say vertical scaling, I basically increase the size, I mean hardware resources of it. So let us basically think of this situation. Okay, right. So basically, if it is horizontally scaled, rather than one, I might have two availability checkers or n availability checkers. Okay, so that is basically what it means, right? Now, but we have to understand certain things over here. So, what do you think is the right number to scale? Okay, so right now the request is 10,000, but it might go till 15,000 or it might come back to 5,000 back. So, how do you basically scale this stuff and what is your metric for this? This is the whole point of view of our discussion. Right now, the traffic is 10,000, good. But will the 10,000 stay forever or will it basically increase further? So how do I resolve the situation? Yeah, I'm unable to see my desktop. Okay. I have reset it. I think you should be able to now. Okay. Okay. Right. So let us basically consider the architecture over here. Okay. So what I'll do is rather than having one availability checker, okay, I'm going with horizontal scaling. You will have two availability checkers. Right. All right. And rather than having one booking server, okay, rather than having one booking server, you might have two booking servers. And in the same way, rather than having one ticket generator, you might have two ticket generators. Okay. So this is the possible solution. Okay. Right. Fine. This is what horizontal scaling will do. And what about vertical scaling? Vertical scaling will basically increase the size of your servers. Right. So let me save as PNG. Let me call it as cloud 7.png. Okay. So preview dot slash images slash cloud 7.png. Now, okay. So Yeah, I'm basically the whole point over here is I'm not speaking about cloud yet. So I know that you would have the tendency of auto scaling and all of that stuff. I'm not speaking about cloud. I'm just speaking about the problems, and we will lead to cloud. We will lead to cloud. Okay, right. So now if you look at it, rather than one availability checkers, I have two availability checkers. Rather than one booking server, I have two booking servers. Rather than one ticket generator, I have two ticket generators. So how will my gateway go to the right availability checker? How will it know? Okay. So because you have more than one server at a time. So for example, assume that this availability checker's IP address was 192.168.10.100. Now we have one more. So it will have its own IP address. Now, how will gateway know whether it has to send to this availability checker or this availability checker? So we need someone who redirects the traffic to multiple servers. That is where we will add something called as load balancers. I'm writing it as LB, load balancers. What is the responsibility of load balancer? To redirect the traffic, to, okay. I'm just drawing one load balancer because it is absolutely possible for you to use one load balancer for many different services. Okay. This might look as a clumsy image, but I am quite sure that, okay, I can do one thing. For booking server, I'll use a blue color. Okay. For ticket generator, I'll be using an orange. For booking servers, I'll be using a blue color. And then I'll be using orange for ticket generators, just to understand that. Now, basically, what is that you have done? To redirect the traffic, you need one more component now. That is a load balancer, because you don't have one server. You cannot rely on the IP address of that. Okay. Yes. Does it make sense now? There will be a need of something called as load balancer now. Load balancer. What is the purpose of a load balancer? When we have more than one server to do the same thing. When we have more than one server to do the same thing, then possibly we might need a component called as load balancer to redirect the traffic between both of the servers. Okay. Yeah, load balancer is a server, obviously. Everything which we are trying to speak over here from gateway is a server. Yes. Okay. Yeah. Now, one unsolved puzzle over here is, what will we do if the traffic comes down to 3000 users? Then the problem with this approach is, when the traffic comes down, you have more horsepower and you are not using that to your efficiency. So each server can do 5,000 parallel requests. Okay. At this point, you have approximately 10,000. So it all makes sense, right? So this cost makes sense. Now, but when the user request comes down, right, it comes back to 3,000. Do I still need two servers? The answer is no, because each server can approximately handle 5,000 users. Now, in these cases, okay, right, we need a way to scale up or scale out, all right, or scale up, okay, which is increase and scale in or scale down. These are the terms which you will see a lot of times, right? Decrease the number of servers based on demand. based on demand. Okay. Am I clear on this? Right. Yeah. So we need an approach. But the problem with this approach is increasing and decreasing the servers. Okay. Is something which we need to find out a solution for this. And cloud has a solution to this. This is what? Okay. Right. In all the clouds, okay, the scale in and scale out is supported and also referred as elasticity. Also referred as elasticity. So terms so far. So I'll define three key terms which we have understood so far. One is availability. Okay. Fault tolerance. And the third one is elasticity. What is availability? Availability is, okay, property or a measure of, okay, system uptime. So for example, if your system is up for 355.5 days of 1 year out of 356. So you do 355.5. So for example, let me do this. Let me do that simple stuff. What is availability? 355.5 days. Oh, sorry. 355.5 divided by 355.5 divided by 356. Okay. Now you, since it is a percentage, you can multiply it by 100. So your system is available for 99.86% of the time. So it is a measure of system uptime. Okay. More available. Okay. If your system is up for majority of the time. Okay. For not majority, I'll put in this way. Majority, almost all the time. It is considered to be highly available. What is it? Highly available. Please understand, these all terms will come into every cloud which you try to learn. Okay. So our design, right, going forward as a cloud engineer is to build highly available systems. Right. At least not all might not require to be highly available, but there are mission critical systems. So where they have to be highly available, right? And then let me define all the three, and then we will basically speak about them. Okay. So capability of a system to recover from failures. For example, yesterday I said, what will you do if your database is crashed? Then the solution of that was, you said that you wanted the secondary database, right? So now we have a capability of a system. Even if the database is crashed, our secondary database will act as a primary database. So the database part of the system is fault tolerant, right? So our system will not get into faults, recover from failures or faults, right? Elasticity, capability of the system to scale up or down depending on needs of the user, right? I'll not say needs, I'll say depending on yeah, needs of the user, is because Whether it is automatic or manual is a choice. I have not defined it yet. Okay. Depending on needs of the user is considered as elasticity. So what is availability now? Availability is how much time your system is up. And as a cloud engineer or as an engineer generally, forget about cloud. Normally in your organizations also, you would like to have your systems which are highly available, And then the next thing is basically fault tolerant. When some of the failures happen, your system should be able to recover from that failures automatically. That is considered to be a fault tolerant system. And the third thing is elasticity. Elasticity is capability of the system to increase. Okay, when I say increase, it could be horizontal scaling or vertical scaling, right? Scale up and scale down depending on the needs of the user. Okay, so what is availability? Availability is a property of the system, right? How much time your system is up and running. So for example, if you are using Facebook, right? Facebook will be running round the clock all the time. Okay, so it is considered to be a highly available system, right? Because it is running all the time, right? But let us assume that if Facebook has a downtime, okay, so now availability is generally measured in percentages. Total time divided by system uptime. So for example, if your system was up throughout the year for 365.5 days, it was down for 12 hours, right? Out of 365 days in a year. So you just do your simple ratio purposes, 365.5 divided by 366 or something like that, okay, into 100. Then you would basically get what is the availability of your system. And your systems have to be highly available in most of the cases, right? Am I clear on this? Okay, can we keep the gateway instead of load balancer, right? So that is generally that is a solution in some clouds, okay, right? So let us basically not get into what is gateway and what is load balancer, right? So gateway was an easier interface for you to get into, right? So, but I'm trying to describe whenever you scale, you might require a load balancer. Whether we can use one for all the things, the answer could be yes. But at this moment, that is not what I am looking out for. Am I clear, Raju and Mani? Yes. Yeah. If I go into that direction, I'll be going into networking. That's the reason why I'm not going into that. So are we clear so far? So yesterday when I said, okay, when the database fails, I have a secondary database. What is that I was trying to do? I was trying to make my system fault tolerant. Why fault tolerant? So that I can increase the availability of my system. Why fault tolerant? So that I can increase the availability of my system. Are we clear on this now? Yeah. So fault tolerant and availability goes hand in hand. Okay. Right. So does it mean that load balancer itself will create extra servers and delete servers as per the user requirements? No, sir. It is not load balancer who creates. Load balancer is like a traffic cop. He can only send the traffic to whatever is available. If it is not available, it will not do anything. All right. Am I clear or is there any confusion so far? Yes. Yes. Okay. Good now. Now, in cloud, all the time you come across these three terms: availability, fault tolerant, and elasticity. Now let us see what else basically comes into play. Right. I have to define an important thing which is called as virtualization. Okay, so before I get into virtualization, I want everyone who decides the elasticity. So that's generally, for example, if I'm running a payroll application is where you can see your pay slips, which is given by your organization and all that stuff, right? So if that application is not available for certain periods of time in your month, it is not a very critical application. But I cannot do the same thing for the application which is basically like stock market application or tax submission application for a government and all of that stuff. The criticality of your application defines availability, and the criticality, once the availability is defined, that defines the needs of fault tolerance, and that defines the need of elasticity also. So it is all your application that will decide. Okay. So every year we submit tax returns, and we submit tax returns only once in a year. So if I'm building really a tax return server, it is not necessary for the tax return server to be up all the time or to be scalable all the time. But whenever government announces that period where you have to submit your tax returns, at that time it has to be highly available. At that time it has to be highly available. That's how it is. So it depends on what application you are trying to build. Okay then. Let me speak about virtualization. Okay, a very important concept. Okay, and our clouds heavily rely on this, no matter whatever cloud which you are trying to speak out for. Okay, so let us try to understand what this virtualization is. Okay, so how many of you already know a little bit about virtualization? Yeah, so what do you mean by virtualization? So, right, fine. Let me try to start with that. Virtualization allows to create multiple simulated environments, or okay, you can call them as dedicated resources. Okay, from a single physical hardware system. Okay, so what do I mean by that? Okay, so let us assume that you have a server, you have purchased a server, a physical server. Okay, let me go with physical server icon. Let me go with this. I'll not go with icon, I'll directly use the image. So, right. Fine. Okay. So, this is a physical server. I'm quite sure some of you who walk in your lab might have definitely looked at this kind of a physical server, right? Okay. Fine. So, now in this physical server, if I have to run an application, so what is it I'll do? Okay, so let me do this. First, you will take a physical server, and then you will install operating system. Okay, or to be very specific, you will be installing server operating system. Okay, and then you will be running your applications. Yes, this is what you do, right? Okay. Fine. Let me share this image first. So you are taking a physical server, you are purchasing a physical server. In that, you are installing an operating system, and then you are trying to run an application. Okay. So right. Okay. So now, okay, to run applications, we follow the above workflow. Now, generally, when we purchase any hardware, will we want to use it to the fullest capability, or do you want to use it to little bit free time and like what we expect in our jobs, right? My job should not be tough, but I should be getting 1 lakh or 1.5 lakh of pay and all of that stuff, right? But right, I'll do that. Thank you. Thanks, Vinit. Yeah. Okay. So now, whenever we purchase any hardware, do we want to run it to the fullest capability, or is it okay for us to run at 10% or 20% capability of the server? Yeah, we want to run it with the fullest capability of it. But generally, when you do this, what happens is, okay, when you try to physically install the servers, okay, yeah, all right. I'll basically use this. Okay, so not looking good. I think this is okay. Okay, fine. I'll do one thing. I'll cut this from here. So when our usage is less, it really doesn't make any sense. Okay. So if you basically go over here and then let me basically do this. Okay. So I'm just writing it as CPU. Okay. The CPU usage on the server. Okay. Memory usage on the server. Memory stands for RAM. Okay. And disk usage on the server. Okay. So usage graphs. Now, if my usage graph is less, this server will not cost very less for me. Because if you understand, to maintain this server or to purchase this server, I have to spend a lot of money first, which I basically call as capital investment. I have to invest a capital. And then to maintain the server, I have to invest a lot for ongoing activities. I should have a closed room with a huge air condition, right? I need an admin to basically take care of it. So these kind of servers, well, they give you a lot of capabilities, right? But they also give you a lot of maintenance overheads. Now, whenever I'm trying to install an operating system and run my applications, and if this is the case, so is it okay to spend your organization's revenue like this? Will your organizations agree if this happens? But this used to happen a lot earlier. Right? So Right. Let me basically put that. Okay. Okay. So when the applications don't use your hardware resources, okay, to the maximum potential, okay, it's waste of cost. I'll put it in a technical term, ROI, return on investment. Return on investment is very low. Okay, and no organization wants that. No organization wants that. So this is where a wonderful solution came into this existence. Okay, so basically, right, in somewhere in 1960s, okay, uh, there was we had seen this technology in its first display. So there, what they have basically done is, okay, let me basically remove this. Okay, you have a physical server. So on the physical server, obviously we'll install an operating system. Okay. So, but what they have started to install there is, they have started to install something called as hypervisor. What is it? Hypervisor. Okay. So hypervisors are the separate softwares which were installed on the physical resources. And what this physical server used to do is, it used to create multiple virtual environments. So now, in the same physical server, rather than running one physical operating system, I can typically write multiple operating systems. Okay. And this each operating system is something which we are calling as virtual machines. Okay. So here I'll be writing it as VM, but understand this. So what is it we have done? We have taken the physical server, that is the rack server like that. So this server has hardware, CPU, RAM, whatever it is. And on top of your physical server, you install hypervisor. You install hypervisor. And then from that hypervisor, you create virtual machines. From that hypervisor, you create virtual machines. Am I clear on this? Okay. Yeah. Okay. So rather than taking one physical server and installing only one application or one set of applications for that, okay, now what you can do is, you can use the same physical server. On that, you can install something called as hypervisor. Hypervisor is basically a software which can create multiple virtual environments. So that virtual environment is nothing but a virtual machine. So this virtual machine will have, okay, operating system. Okay, so here I might tell that this virtual machine will have Linux as an operating system. Okay, so this virtual machine you might go with, okay, Ubuntu. Okay, another flavor of Linux. And this operating system or this virtual machine might have Windows. Now, rather than running or executing only one kind of an operating system on your server, now you have a capability of running multiple operating systems on the same physical server. Okay. And by the way, this is called as server virtualization. This is called as what? Server virtualization. Am I clear on this? And all of your clouds use this. Okay. If your company is using VMware, they use the same thing. So what is happening? From one physical machine, we are able to create multiple virtual machines. Okay. Right. So let me store this. Okay. Okay. So rather than using one operating system on the physical server, we can create multiple, okay, virtual machines, okay, on the same physical server. And remember, this kind of virtualization is called as server virtualization. Okay. So now let me try to tell you, get into the server virtualization. Okay. So will this physical server have a hard disk? Will this physical server have a hard disk? Yes or no? Okay. It will have a hard disk, right? So let me use this, or let me use this. This is looking like a physical disk. Okay. So it will have hard disk. Okay. Now, will this virtual machine have a hard disk? The answer is yes. Okay. But it will have something called as okay. I'm just drawing only to one machine, but please understand it is to all the machines. Okay. So each machine will have, okay, what is this? Virtual hard disk. Am I clear on this? So on the physical servers, we have physical hard disks, and on the virtual machines, we'll have virtual hard disks. All right. Okay. Right. And this virtual hard disk is basically created, okay, somewhere on your physical, from your physical machine. Okay. In most of the cases, in cloud, they work slightly in a different way, but it's okay. Okay. So here what I'm trying to do is I'm trying to draw 3 virtual hard disks, okay, which are basically created from the same physical server, okay, and these are called as virtual hard disks. Okay, I think, yeah, you can understand that. And these virtual hard disks will be mounted, okay, onto every VM. Am I clear on this? Yes, right. Okay. Now let me come to the next important. I'll be just drawing important stuffs. Okay. So, and I'm quite sure that this physical server will have a CPU. Okay. This physical server will have a CPU. Right? Your virtual machines also will have CPUs. Your virtual machines also will have CPUs. But understand one thing, your CPUs are also, okay, the CPUs I'll draw it within here. Okay. Your virtual machines also will have CPUs. Okay. And these CPUs, much like your hard disk, are basically, whenever you run anything, they rely on the physical server's CPU. But each machine will have its own boundary. They will be given allocated some amount of CPU. So will your physical server have a RAM? Yes. Yeah. Right. So your virtual machine also will have a RAM. Let me use some other. Yeah. Your virtual machine also will have a RAM. Okay. So, but understand one thing, whatever your virtual machine gets is generally virtual in nature. Am I clear on this? So now your virtual machine is getting a virtual CPU, a virtual disk, and a virtual RAM and a virtual RAM. Okay. Now let me finish this and then I'll speak about it. So all right. Your physical server will have some kind of network sockets. Okay. Yes, do you agree to this? Okay. And okay, right. Let me put it in this way. Okay. So this is a physical network which your office has. Okay. And your servers are generally connected, okay, to this physical servers network. The reason why I'm drawing two sockets is you can have two sockets. Okay. But understand one thing, your virtual machines also will have a network. There is no doubt about it. They will also have a network. But only one thing to understand is they will not be connected, okay, directly to a physical network. Okay. Okay. This is a virtual network socket. You will have, okay, a virtual network. Am I clear on this? So your system will be connected to virtual networks. Am I clear on all of this? So whenever you use a hypervisor, right? Hypervisor is basically created on a physical machine which has all the physical hardware resources. But using that physical hardware resources, what we do is we tend to create, okay, things which are virtual in nature. Things which are virtual in nature. So, for example, you would have a physical CPU, okay, but what your virtual machines get is they get a virtual CPU, but that virtual CPU will rely on some of your CPU components. Here you get a virtual RAM. Yeah, your virtual RAM will rely on a physical RAM. Here you get a virtual network. Your virtual network might rely on an actual network that is connected to your system. So that is how the whole virtual machine concept works. Okay. And understand one thing, this virtualization is very, very popular and all the clouds adopt this virtualizations. So cloud 11. Okay. I'm not writing too much about it, right? So every virtual machine gets what? Virtual disk. Okay. Is connected to virtual network using virtual socket, gets a CPU and memory. Again, they are virtual. Okay. And generally, every virtual machine also has some operating system. Operating system. Am I clear on this? Yeah, it is Nick. Yes. Is it all making sense now? Okay. Now, in the cloud, for example, you might have heard people saying that in AWS, I have created a EC2 machine. In Azure, I create a virtual machine. In Google, we create a Google compute engine, whatever you call it as. Basically, what we are trying to create is we are trying to create virtual machines. Okay. And server virtualization is supported by softwares like VMware. Okay, so VMware is very popular in this world. VMware ESXi. Okay, so there are many other old stuff, but I would just basically write about VMware at this moment. Okay. So there is virtual desktop infrastructure and all of that stuff also, but I'm not getting into desktop virtualization at this moment. So if you understand the server virtualization, this is what it is. Okay. All the clouds use server virtualization, okay, for creating virtual machines. Amazon calls it as EC2. Azure calls it as Azure VM. Am I clear on this? Is it making sense now? Yeah. So you go to any cloud, the story is same. Okay. Everything virtual machine is gets from a physical server. Yes. Yes. Everything virtual machine gets is generally from a physical stuff. Clear on this? Yeah.
Thanks for watching. For more videos, subscribe our channel and click on bell icon.